So now we're going to use exponent rules. So those exponent rules we talked about in previous videos, and we're going to apply it with rational exponents, fraction exponents, okay? So if you think back, when I had x to the, 2 multiplied by x to the 4, same base, x and x, I added the exponents, 2 plus 4, and so I got x to the 6, right? So it's the same thing going on with rational exponents. I say x to the 1/2 times x to the 2/5. Same thing, same base, add the exponents, 1/2 plus 2/5. Now, to add fractions, you got to have the same denominator. We don't have the same denominator yet, but to do this, I multiply top and bottom over here by 5, and multiply top and bottom over here by 2. And so what does that get me? That gets me x to the, 5 over 10 plus 4 over 10, which is x to the 9 over 10. Now, say you're a little rusty with adding fractions, okay? Let me show you how to do this in the calculator. All right, 1 divided by 2. Oh, this is really hard, guys. And then plus 2 divided by 5, enter. 0.9. Oh my gosh, I don't know what 0.9 is in fraction form. Guess what? Hit the math, frac button, hit enter, and you got it. 9 over 10 right there, okay? So this form, this is in rational exponent form. So if they tell you to put it in rational exponent form, do it like this. If they don't tell you anything and you start in rational exponent form, finish in rational exponent form. But if they say put into radical form, how are you going to put it into radical form? You're going to take the rider and the horsey. The rider is the 9. And I'm going to put that on the inside, and the horsey is the 10, and the horsey goes on the outside of the house. And that is the radical form right there of that answer, okay? So unless you're told otherwise, stay in the form of the problem that was originally given to you here, okay? Try another one. 4th root, 7, multiplied by the 16th root, 7. Now, how do we do this? Different indexes. So first thing I'm going to do is I'm going to convert. So I convert this to 7 to the rider and the horsey. Horsey goes on the bottom. Rider goes. Uh-oh. What is the rider for that 7? Well, the question is, how many 7s are in there? There's just 1, so the rider is 1. Okay? And then multiplied by 7, and then the rider is 1, and the horsey is the 16. Same base, add the exponent. So that's 7 to the 1/4 plus 1/16. You can type that in your calculator if you want to. You can do your old school way of getting a common denominator, least common multiple, multiply through. So 4 over 16 plus 1 over 16 gets you 5 over 16. So this is 5 over 16. Now, we started in radical form. I'm going to finish in radical form. It's the 16th root of 7 raised to the 5 power right there. Okay? If you type it in, maybe your homework system is going to want you to multiply this out. So 7 to the 5. 7 raised to the 5 power is 16,807. And it's the 16th root of that. So maybe that's what they're looking for. Okay? Alrighty then. Let's try some more. Y to the 4/3, z to the -3/2 divided by y to the 1/3 z. Okay? So I'm going to simplify here. First thing I'm going to do is I'm going to take care of my negative exponents. So negative exponents, there's only 1 here. So how do I get rid of it? I flip it to the denominator. It becomes z to the +3/2 And then what do I have? I have y to the 1/3 z. Now there's only one of those z, so we'll just put that 1 right there. Okay? All right. Now, same base, I combine. Okay, so this is y to the 4/3 divided by y to the 1/3, and then multiplied by z to the 3/2 plus 1. Same base, add the exponents. Same base, and we're dividing, then we subtract the exponents. So we're adding for multiplying and subtracting for dividing. So whenever I do that, what do I get? This becomes z to the, 3 divided by 2 plus 1 is 2.5, math bracket, 5/2. So 5/2 for that part right there. Now, what about this here? I'm dividing, so what do? I subtract the exponents, y to the 4/3 minus 1/3, right? Okay, and so 4/3 minus 1/3 is 3/3, and so this becomes y over y to the 1 over z to the 5/2. Okay, so my answer started in rational form. I'm going to finish it in rational form. Y over z to the 5/2. Okay? Do a couple more and we'll be finished. All right, so 3x to the -3 times 8x to the -2 times x to the 1/2. Now, same base, we add the exponents. So what are my bases here? Well, I have a base 3 and a base 8. Those aren't the same base. But a base of x here, a base of an x here, and a base of an x here, those are the same base. So I have 3 times 8, which I can't combine. But then I have x with a base, and I have a -3 plus a -2 plus a 1/2. Okay? So 3 times 8 is 24. And this is x to the, now, -3, -2 is -5, plus a half is -4.5. So -4.5, we can go in here, -4.5, okay, math frac, that's -9/2. So this is 24, and then x to the -9/2. What do we do with negative exponents? Do the reciprocal. What's the reciprocal of x? It's 1/x, so it's 24, and then 1/x to the 9/2. Okay? And so maybe it wants you to write it as one thing, so that's 24/x to the 9/2. Okay? But that's how we get from here to here. One more problem. I have x to the 1/3, and then I have z to the 2/3, all raised to the -2. Okay, this is a power to a power, so I'm going to multiply power on these exponents. So this becomes x to the 1/3 times -2, and then z to the 2/3 times -2. And when I multiply, I get x to the -2/3, and then z to the -4/3. And since those are both negative exponents, I do the reciprocal. So I flip it over, it becomes x to the 2/3, and then z to the 4/3. Just like that, and that's my final answer right there. Okay. You can leave it in this form right here, and that will be just fine. All right, guys, good luck.